Assalamualaikum, I'm Tasmin Jahan Mithu. Today I'm going to talk about what is ground reaction force exactly, ground reaction forces in normal gait and in prosthetic legs. Phases of gait. There are 8 phases of gait. Initial contact, loading response, mid stance, terminal stance, pre-swing, initial swing, mid-swing, and the last one is terminal swing. This part of the video, I'm going to talk about ground reaction force. Ground reaction force is the force exerted by the ground on body in contact with it. This concept is rooted in Newton's third law of motion, which states that every action has an equal and opposite reaction. If we want to see in practical terms, when you stand on the ground or in walking or running, your body exerts a force downward due to gravity, especially it's your weight, and in response, the ground pushes back with an equal force upward. This upward force is mainly ground reaction force. Due to ground reaction force, the center of the pressure first goes on the heel, then mid-foot, and then toes. Ground reaction force in normal gait. In my previous video, I have already briefly described about how the ground reaction force acts in normal gait. I'm going to shortly describe it. Initial contact from knee to ankle, it goes posteriorly, anteriorly, anteriorly. Loading response, posteriorly, posteriorly, anteriorly, mid stance, anteriorly, anteriorly, posteriorly, terminal stance, and in pre-swing, it goes anteriorly, anteriorly, and posteriorly. How the ground reaction force works in prosthetic legs. Shortly after heel strike, in normal gait, the action line of the ground reaction force passes behind the knee joint, causes a knee flexion moment. The knee extension act to control the amount of flexion. But in amputated gait, because of the flexion moment and the action of the quadriceps muscles, there is a tendency for the stump to change its angulation in relation to the socket. Therefore, it causes pressure in the anterior distal and posterior proximal. We can see the arrow goes anteriorly and posteriorly. During mid-stance in normal gait, the action line of the ground reaction force passes anterior to the knee, creating an extension moment. The body is moving forward with a rolling action over the ankle joint. Dorsiflexion is controlled by the soleus and gastrocnemius muscles. But in amputee gait, the prosthetic's leg has limited dorsiflexion action at the ankle. Therefore, as the body moves forward, the stump will tend to change its angulation in relation to the socket. Therefore, this pressure on the stump are anterior proximal and posterior distal. And then for the push-off phase, in normal gait, as the body moves forward, the line of action of the ground reaction force moves more and more posteriorly to the knee joint, creating a flexion moment. But in amputee gait, because of the flexion moment and the action of the quadriceps muscles, there is a tendency for the stump to change its angulation in relationship to the socket. Therefore, it causes the pressure on the stump are anterior distal and posterior proximal.